Hi dear students and viewers. As part of this chapter, we discussed about the photoelectric current and what is the relation between the photoelectric current and intensity of radiation. We clearly discussed those things in previous videos. So up to now you didn't see those videos, just go and watch them. After watching all those two videos, then only you must come to this video. Otherwise, you will not get anything from this video. After watching the previous videos only, you must come to this video. Okay children, here today our topic is effect of frequency of incident radiation on stopping potential. And what is the relation between the frequency and stopping potential? At the same time, the relation between the frequency and photoelectric current. We discussed what is the photoelectric current. When certain intensity of light of certain radiation of frequency is incident on the any metal surface, then the electrons are emitted from the metal surface. That phenomena what we call photoelectric effect. When certain amount of frequency of radiation or amount of intensity of radiation is incident on the any metal surface, the electrons are emitted from the metal surface. That phenomena commonly called as photoelectric effect, and the electrons which are coming from that metal surface are called photoelectrons. I clearly explained in the previous video how the process will be there in photoelectric effect with one experiment. I clearly explained that one. So here children, we know that we have some idea about the work function. So while explaining the Einstein's photoelectric equation, we discussed this is the one discharge tube, and this is the one metal plate, and this is the another metal plate B. What we taken that is on the time A is the cathode and B is the anode, or nothing but collector. B is the collector, and here there is some one quartz window, it is there, and the light should be incident on the metal plate through the quartz window like this. This is what quartz window. When the light is falling on the photosensitive metal like A, then the electrons are emitted. These electrons are moving towards the collector. What is the B? B is the collector. The electrons are coming from A and they are moving towards B. So here that amount of energy what it is falling on that one metal is E is equals to H nu. E is equals to H nu. What is H? Planck's constant. What is nu? Frequency. That means here the energy what it is incident on the metal surface, that will have some frequency. Clear? So the light what it is falling on the metal surface, that should be having some frequency, at the same time intensity, at the same time wavelength. So here according to the Einstein's equation, what we discussed, E is equals to, or energy H nu is equals to H nu naught plus of mv square. Here H nu naught is what we call work function, and half mv square is what? Kinetic energy, and H nu is what? Amount of energy what it is incident on the metal surface. So children, when the light is incident on this one, I mean light means nothing but energy. The energy what it is incident on that one, H nu, and that should be equal to the work function and half mv square. Here work function will explains the minimum amount of energy required to remove the electron from the metal surface. To remove the electron from the metal surface, that is what we call work function children. Here you have to understand that one. Here the intensity of light which is incident on the metal surface, that will decides the photoelectric current. Already I explained what's that. When intensity is more, photoelectric current also more. Clear, children? So once the light is falling on the metal surface A, electron is emitted because of photoelectric effect. So then the emitted electron must move from A to B, because B is the collector. Collector will collect all the electrons. So for that some energy is required. Some energy is required, and that energy is here what you are showing of mv square. So that means the electron is moving from cathode to the collector. That means it is in the motion. That's why you will experience some kinetic energy. So the energy, what it is, kinetic energy, that should be depend upon the frequency of radiation. Frequency of incident radiation. Got my point? You have to remember one thing here. While we are discussing about the photoelectric current and intensity, we concluded that there is some directly proportionality between the intensity and current. When intensity of radiation is increases, at photoelectric current also increases. It means that what? The number of electrons, what we discussed, photoelectrons mean nothing but which are emitted from the cathode. Those are taken as photoelectrons. The amount of electrons should be collected by the collector, that will use the photoelectric current. When we can increase the intensity, amount of collection of electrons also increases. It means that when the intensity increases, photoelectric current also increases. Okay, children, in this one you have to remember that when the intensity is more, photoelectric current is more. So while we are discussing that, you have to remember that on that time frequency is constant. We are maintaining the frequency is constant but increasing the intensity of radiation, then photoelectric current is increases. Clear? On that time frequency maintain constant. Okay, children, now here my aim is to say simply the kinetic energy of the electrons, that should be purely depend upon the frequency of incident radiation, but it is not depend upon the intensity of radiation. The number of electrons are liberated from the metal A, that should be purely depend upon the intensity but not frequency. But the moving of electrons from A to B, that will depend upon the frequency of incident radiation. So you have to remember that quantity of photoelectric current depend upon the intensity. At the same time, the kinetic energy of the electron should be depend upon the frequency. That is the first point you have to remember. The photoelectric current is independent of frequency, but the kinetic energy of the electron should be depend upon the frequency. That is the first thing you have to remember. Okay, children. Now here, children, we are having one diagram on the board. You have to observe this one. So this is the x-axis. From this is the origin, and it is the positive x-axis, and this is the negative x-axis. What we are taken along the positive x-axis, we are taken collector plate potential. That means here the positive values of potential. And next thing is what it is here, children. The collector potential value is decrease. Retarding potential. Clear? And on y-axis what we have, children? Yes, this is what? Photocurrent. Now we want to compare the frequencies, potential and photocurrent. Here what I am going to say is nu1, nu2, nu3. We are not saying I1, I2, I3 like that. That means what? In this case, intensity is constant. intensity is constant. For same intensity of light, we are having different frequencies. So this is the first thing I am going to say, I1, and this is for I2, and this is for I3. That means what I have to say, I1, I2, I3 intensities, I1, I2, I3 all are same. But what is the difference? Even this is the I1, but its frequency is nu 1. Its frequency is nu 1, and its frequency is nu 2, and this frequency is nu 3. So this is nu 3, and this is nu 2, and this is nu 1. So when we are taken same intensity of light but different frequencies, then we are getting the graph should be like this. So here from the diagram you have to observe that the first thing is here the value of current is same. What it is that saturated current, saturation current is same. The intensity is same. That's why current also same. Here, as I told you in previous videos, when collector potential value is increase, when value of B is increase, then the collector will resist the more number of electrons which are coming from A. Got my point, children? When A value, this is A and this is B. Already A is given to negative, B is given to positive. When the value of potential of B is increase, it is positive value is increase, then what you have to say, it will collect the more number of electrons. Electron charge is negative and B charge is positive. So then the current will be S, increase. When the value of collector potential is increase at particular value of potential, the current will be maximum. That current is what we call saturation current. Saturation current. So from this diagram you have to know that all are having same saturation current. Clear? But when the value of B means what here, collector, when the potential value of B is decrease at particular one potential, the photocurrent will be 0. That potential is what we call stopping potential. I clearly explain what's that. When the value of potential value of collector is decrease gradually at particular one value of potential, photocurrent will becomes 0. That potential what we call stopping potential, or it is also called as cutoff potential. So that's why, children, here from this graph you have to first thing is what we are measuring, intensity is constant but frequencies are different. When we have like that, for collector potential is when it is increase, they have same maximum current, that is what we call same saturation current. And the second thing is what, children, when we are taken value of collector is negative, that means we are decreasing the value of potential of collector, then here for every frequency of radiation there is some specific stopping potential. Even though they have same saturation current, their potential, stopping potentials are different. That is the second point you have to remember. Clear? Even though intensity of radiation is constant, different frequencies of radiation has different stopping potentials. So when, clear, children, when the value of B is decrease, stopping potential value becomes 0. Okay, what I'm telling, when frequency is different, stopping potential also different. That is the you have to remember, children. And next thing, third point, at stopping potential, the value of frequency of radiation, that should be called threshold frequency. The frequency of the radiation at which the stopping potential becomes zero, that should be what we call threshold frequency. Below the threshold frequency there is no photoelectric current. That's you have to remember. Clear? When we go for nu naught, this is what V naught 1. V naught 1 means what? This is the stopping potential of first in frequency nu 1. So when we come to this downward stage, there is no current, we are not showing. That means what? Above this value only there is some current. That means below the cutoff potential there is no photoelectric current. Same as what you have to say, at stopping potential there is some frequency is called, that is what we call threshold frequency. For that threshold frequency, below of that one, below the threshold frequency there is no photoelectric current. You have to remember that, that is the important thing. Clear? And next thing is, children, different materials have different stopping potentials and different threshold frequencies. Clear? When we are taken only one material, one conductor, one metal, then we are having like this. In this case what it is? Metal is same, but intensity of frequency of radiation is what? Different. So when we are taken different type of materials, for example, A is first we are taking one type of material, next we are replacing some another one. Then also we are getting the different threshold frequencies and different threshold potentials or cutoff potentials. That's what I have to learn. Different metals are having different stopping potentials and different threshold frequencies. So children, this is simply about the effect of frequency of incident radiation on stopping potential. So again, simply I am remaining only 4 points. The first thing is, photoelectric current is depend upon the intensity only but not on frequency. And second thing, the kinetic energy of electrons is depend upon the frequency but not on intensity. And third one, when we are maintained intensity remains constant, different frequency of radiation have same saturation current but they have different stopping potentials. Clear, children? And next thing is what I am going to say, less than the threshold frequency there is no photoelectric current. What is threshold frequency? The value of the frequency of radiation for stopping potential, that is what we call threshold frequency, or the minimum frequency at which for the stopping potential is called threshold frequency. And next thing is what? Different materials are having different stopping potentials and different current, different stopping potentials and different frequencies, children. So this is simply about the topic what we are discussing now, children. This is important 4 marks. So I hope you understand. If you can understand this one, like, share, comment the video and subscribe my channel to get all the notifications. We will meet in the next video with some other interesting topic. Bye. Take care.